We are setting up to do a velocity and acceleration lab today. And we are going to perform this lab by collecting data with this calls it a recording timer, 110 volt. And that's the box this came in, and you can see this is relatively new, even though when you take the device out of the box, it looks really, really old school. And it is. This is a very, very classic physics labs to do. Let's just talk about what this device does. This device, when you turn it on, the little on switch here, has a little arm that is going to be oscillating up and down. And when it does, okay, it's going to do a little tapping on a little metal surface right there. And how much does it tap? It taps. The oscillation is at 60 hertz, and that means 60 times a second this little arm is going to vibrate and tap up and down. Okay? Now, how are we going to turn it into something visual and something that how we can collect data with? And in a sense, we are going to be able to see time is with this little disc right here. This little disc is a piece of carbon paper, and most people don't know anything about carbon copies anymore. But back in the day, when people didn't have copy machines, they put a sheet of carbon paper between two pieces of paper and would write. And as you would write on it, in fact, I can maybe try to kind of perform that, make a little mark. Here's our lab sheet for today. Ooh, it's getting awfully overlit there. But if I were, let me on the top edge, to use my nail on my little lab sheet, see if it can, it's having really trouble focusing on that white. But it left a little mark on that. Okay, so there's material on there, I assume it was originally carbon, that is going to get transferred to some paper that we are going to put through here. So first, we're going to put that little disc, the carbon side down, right there in here. And then we are going to get our, so on a spool like this is some ticker tape. And I have a piece here, and I will show you how this functions. So I'm going to put it right through so that the ticker tape, sorry, it's got a little bend, is going between the disc and the little metal plate that's underneath there, okay? So I'm just going to fish that through. And I'm going to turn this on, and then you're going to be able to see what craziness this is, okay? Sounds a little bit like a dentist drill. All right, so here we go. And I'm going to try to pull. Okay, and we now have, let's see if I can get this to focus. Come on. I was doing better earlier. Come on. Can you see the little dots? I'm going to back it out a little. They're pretty faint. You can see the big smear of where it sat a long time. And then I'm hoping, let me see if I put it face down for a second. I have actually two strips here. I'm going to rip one off, and I'm going to put it by a ruler here. And I'm going to take my camera and see if I can orient it downward. Do you see those dots now? Okay. You see the big smear of dark and then a bunch of dots. Okay? And it seems to take a second to focus. You can see the lower one for sure. There you go. It's pretty faint on this. You have to really look. This camera is having a little bit of a hard time focusing in on that. All right, but so that's the concept. Now, if this thing can make 60 oscillations a second, so 60 marks or dots per second, then we also know, as it states on the lab, that if you count out 6 dots, that's going to be 0.10 seconds, all right? So you can see time on this. We know how much time has elapsed, okay? All right. All right. So, and many times the beginning information is not so good, so we normally kind of skip some of the beginning, and then if we got some good data, we're going to then use the rest of it. And again, every 6 dots is 0.1 seconds, and we are able to mark out time. And if we have time and we have distance, because we're going to be attaching this to our little vehicles that we have sitting here, we should be able to find out the velocity. Now, what kind of velocity is this? If I have 0.1 seconds and I have, let's say, so 6 marks, and some kind of distance right here, what kind of velocity? Am I going to get instantaneous velocity, or am I going to get average velocity? Well, I'm going to get an average velocity, an average that happened in that time interval of 0.1 seconds. All right. And of course, the smaller interval of time, the closer something would approach instantaneous velocity, but it definitely is an average velocity in that 0.1 seconds. Okay. All right, so let's try to do this first trial, and I might break this video up into a few different things just to be able to set up for every new trial of information here. Okay, so I got my ticker tape timer, which I should probably clamp down, but instead I'm going to get a heavy weight and put it on it. All right, what do I got here? All right, I'm going to put a little 1 kilogram weight on top of that to keep that from moving. Okay, you can't quite see it. Let me move it a little bit so you can see. Oh, move this down a little. Move this out a little. Okay, so you can see my ticker. Oh, I got to turn it. Got to turn it so it is, so the paper can go through. The lab says, how much do I get? About 1 meter. I'm going to be a little extra safe and get a bunch out here. Okay. And I need to get my tape, and I'm going to take a piece of tape and tape it to one of my vehicles. All right. I've been struggling with some of these cars, but I'm going to get this vehicle out right here. I'm going to run the tape, again, through the ticker tape. All right. Oh, this is a little bit finicky. This is why you should be doing the lab for real, because you get to learn all this trial and error stuff of trying to make things work properly. All right. And the goal is I'm going to turn this guy on. Hopefully it starts to move. And, and I need to first, you need to make sure your ticker tape is not going to get caught up in anything. It needs to be completely flat, and so nothing to encumber that. All right, you need to make sure the tape is below the carbon and the metal plate. So again, that it's getting sandwiched between there. Okay, I'm going to try to turn on both. It, of course, would help if you had a lab partner to do all this. I'm going to turn the ticker tape timer on first. It's just going to leave a big mark while it's not moving, and then I'm going to start the car. Okay, go off the wall, flip it over. All right. Okay, I have a lot of data there, more than I need. So, in fact, I'm going to break it off where there is no more marks. So, here is my data I have. And if you have trouble reading this, I think I'm going to make some pictures of this, and then so I'm going to lay a ruler on it. I'm going to see what we can do. And I'm going to ruler across this information. Again, I'm having a little bit trouble with light and seeing what it can do. Let's see. I don't know. Oh, there's our bells going off. But we're not leaving. I'm trying. Hold on a second here. What you see. So I'm going to hold this for a second here. But I think I'm going to have to take a picture of this. So that might be the solution. I don't know if you could see that, because it seems to be really bleaching out the white when I do this, but I'm going to save this one. In fact, this is the best way to do it. I need to mark this one. Hold on, let me get a pencil here. All right, the teacher's not completely prepared here. All right, I'm going to mark this one number 1 so that we don't get this confused. Whoa. So we don't get that one confused. All right, and then, isn't this just like Labs Go? So we're going to keep this one. I put a number 1 on that, and so then we're going to get data out of that hopefully in a little minute. I'll take a picture of that. Okay, so now we're going to run this again, and I used to do this where students just pulled slow and fast, but it was very hard for them to pull uniformly. And I have little cars now, and I try to get cars that have different speeds, but I'm struggling with that too. Let me try this one. They're a little bit different in speed, but not a gigantic amount. So we're gonna hope we're gonna be able to see that in the data. Okay, I am again going to tape my vehicle with the ticker tape. And I'm going to do the same procedure. I don't remember how to turn this guy on. Oh, it's on the bottom. Okay, so I'm going to turn this on, and we're going to roll through this again. Wow. I don't know, he seemed faster. In fact, let me evaluate real quick. Yes. All right, I can see, I was just comparing the ticker tapes, and I can see it was faster. Can you already think about what I was looking at? How would I know if it was faster based on looking at the ticker tape? All right, think about that question. Of course, you're going to be asked that question on the lab. All right, I just marked that one, ticker tape number 2. And so again, that data will be available for you. That's what we're going to have. All right, once that you're going to evaluate that, you're told on what to do here. You're going to have different times. We know it's going to be the time interval. I think we are doing 0.1 time intervals. You are going to measure the displacement, and the displacement's always from the first position, distance from 0. And then you're going to be calculating velocities. And you're going to do this for trial 1 and trial 2, so ticker tape 1 and ticker tape 2, okay? And then you are asked to make a graph of both of them. You will put, sorry, I don't know why it's struggling with that white paper. Okay, on this graph, you're going to make 2 graphs in one. All right, so make sure you label the horizontal and vertical axis with both the units and the type of measurement. And then you'll have 2 lines on there and label which trial is which line, okay? And then there's some questions to answer. Please be complete with these questions. Be complete that I understand. You're going to use terms and concepts again from our lecture, and be really clear what these graphs show. So use graphing terms like slope, etc., and then terms again that relate to velocity and acceleration. Okay, so I'm going to break this into 2 videos, and I'm going to set up for experiment 2. All right, this is the second half of our video on using a ticker tape timer to be able to notice what happens with velocity and acceleration and see a graphical representation of that. So I had to cut away because I had to set all this up. So basically I got a lab stool with a piece of wood here and my ticker tape timer cantilevered out here with some weights just keeping this all from falling over. And here's the ticker tape timer. I've run the paper through, and I've been really cautious with this because As we know with labs, we don't want anything to kind of mess up our results or be a factor. And definitely when I started to pull on this ticker tape, I could feel some resistance. So that means there's a little bit of friction there that could kind of affect our results a little bit. In fact, I'm moving this paper. The key is really make sure your paper is as straight and parallel and linear without being caught up, no twists in it. Straighten it out again. And then over on this side, what I've done is I've taken a 100-gram mass and taped the ticker tape onto this. And I'm going to try to back it up a little bit. Okay, this is going to be all. And I had to make sure then this mass, when it falls, is outside of my lab table so it doesn't go hitting onto the lab table. And then I've put a little piece of tape here, just clear tape, because I felt the edge of that ticker tape timer as I let this go was going to be, again, some resistance or some friction there. So anything I can do to make better results is definitely what I am trying to do. Let me wrap this tape around here just a little bit better. All right, and then I think we are ready for our trial. So I'm going to turn on the ticker tape timer and I'm going to let go, and we're going to take a look at the tape. And again, I will take pictures of that tape and see what happens here. Okay, so here we go. All right. Okay, not bad. All right, and so, ooh, can we see this? Maybe on this? Okay, there's the start. We can see this time. And you can see the spacing of the dots. And then I'm gonna move it a little. And hopefully you can see the data we have here. All right, and yeah, so hopefully we can get some good information out of that. Hopefully that one worked out quite well. Okay, I think that is it for the actual procedural part. And you were supposed to notice some things when I just showed you that ticker tape, by the way, that did not look the same as when we did the little cars. Moving at constant velocity. And then for part 2, we just did this. You are going to do the same procedure, but realize we're going to use a smaller time interval because we're not going to have enough data. Otherwise, this happened really fast. And so we are using 0.05 second intervals, okay? And use the dots as early as possible. Because the early data is important to be able to see what is actually happening. And again, so we have our time, start probably at time 0, time 0.05, 0.10, etc. And then displacement, and then you are going to find, again, those average velocities. And then we hopefully should be able to graph that information. 2 things we are going to graph here. One is displacement versus time, okay? And that should be one particular shape. And then you're going to graph velocity versus time. And it says to make a best fit line. We are not using our calculators or anything like that. I mean, I guess you could graph this using your calculator and print it out or whatever, and you could tape it on here if you really want to. But since the data is really not perfect, I think you're just fine doing, kind of an old school graph. Best fit line, you're making a line to take into account an average. Realize this average velocity, the points aren't perfect, and you're going to make a best line, straight line, to estimate the data, which means you should have as many experimental points above as well as below that line, okay? And then the rest is just calculations and some questions to see if you understand theoretically what is happening with this lab. All right, so make sure you take a look at all the pictures and do your best measuring, making the measurements from those pictures. All right.